Good afternoon, YouTube. Needlebender785 Ohio with the follow-up video for the dual tube GS-35b build. We got some progress done on this tube. As we mentioned in the previous video, we got the bottom deck fully complete. All I have to do is drill some holes over here and put those actually over here where those switches are coming out, power and all the fun stuff. So that just needs 4 holes and we're done. Now, the thing that is completely not complete, and I'm just getting started on, is the power section. High voltage power section to be exact. And this is the cavity for it. This is where the transformer, rectifier board, and the capacitor bank with all the meters are going to be right here. And that's the only piece of the puzzle that needs to be built. Here's the actual PA section, the power amplifier output section of this thing, which I just got done building, and thought I'd play around with the output tune, and I turned it on and I turned one knob half turn and this thing just tuned right out. I mean, I have not seen this in any of my previous builds with how easy it is to tune this thing. And got the big coil on top, and the only thing that kind of might confuse some people, and that's because the way people are used to is the tune is usually on the left side and the load's usually on the right side. And here you got them backwards, and that's because of how the tubes are positioned. So you got your tune on the right and load on the left. So something to keep in mind. So let's go over through this stuff. So we got the bar, shorting bar between the anode caps, and we have a little anti-parasitic, which I heard is a kind of a good idea. It's not required, but it's a good idea for this build. Kind of eliminates any unwanted high frequency oscillations. Kind of like what happens is since this is kind of it's a cavity, whether you like it or not, and it kind of creates, if you're ever familiar with the theory of magnetron, RF cavity. That's what it can do. And the way, and again, things have to fall, you have to be on a certain frequency, basically kind of like it's a self-resonance kind of deal. And it starts to self-resonate, and it's kind of like creates an RF cavity. And in order to and the way we get around it is we put this parasitic, because we basically add some length to it that the RF, high frequency RF, does not like. And that's what we got going on there. So we got the plate choke right there. Input plate choke capacitor. Comes in here, feeds both tubes. Then you have a shorting bar over here to this blocking capacitor, which is 1000 puff at 15 kV RF rated capacitor. And then we have our tuning coil, which is 3 turns around the 3-inch. We have a 15 kV 0 to 250 capacitor, and we have a 5 kV 0 to 1000. When I say 0, it's like 5 to 1000, and this one's like 7 to 500, I believe. And that's what you need. But this one needs to be rated at slightly higher voltage than this one, because this is your tune. It's closest to the tube. You're dealing with high impedance and then transforming this to 50 ohms. Then we got the RG393 coax, which is like probably the best coax you can use for this. It's like $17 a foot if you buy it from ICA Manufacturing. Then it goes into this vacuum relay, which right now, as you can see, I have it shorted. That's just for testing purposes. And this is our bird output connector for dual line section. And then right here we have our glitch choke, and it's an extremely oversized choke. You do not need choke this size if you're looking to build this. The reason why I went with this is I wanted the wire on this choke to be insulated because of the proximity to high voltage. Now we do have an 1.5-inch gap, which is plenty on its own to keep 4,000 volts away from this, but this wire, insulation on this wire, does provide some additional protection from any kind of arcing. And this is connected to the tube to the side of the power feed on the side of the relay that stays kind of hot all the time. So if there's any high voltage ever making this out from through this blocker, it'll travel through here, 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 through the coax, and then we'll glitch out the ground and short out anything before it ever makes it out of the amplifier. The things that I have not done yet is pass-through tune. That usually requires addition of 2 small capacitors, and this is not the knob, and obviously there's no knob here. There's going to be big, if you ever watch my previous videos of my 3CX3000 build, I use these knobs. They're made for adjusting a lathe. Actually, that's where I get them for. It's they're lathe knobs, and that's what I use. They're big, beefy, half-inch shaft kind of knobs. They're really, really pleasant to play with. No pun intended, of course. Anyway, so we got 100 ohm, 200 ohm resistors at 5 watts, so that creates 50 ohm. Again, that's part of our anti-parasitic little trap here. And over here we have a emulated resistance. So this is a 1500 ohms, because that's about the highest load this thing is going to experience at max power output. And the formula, there's a formula for that if you want to calculate. And I know it's not, you know, you have to know exactly where your power is. That's why, and this is one of the reasons, every time you increase drive, you have to retune. So when you've retuned for the highest power that you talk, you can always go lower, and you don't have to retune. Now, you're not going to get the best performance, but the amplifier is going to be linear up until that point. What you don't want to do is have something tuned for low power, which will give you higher gain and will work just fine. Let's say let's say you're driving this with a 100-watt radio, nothing else. And I've actually driven my 3CX3000 with 10 watts. It works. If you can tune it, and it will work just fine. However, what you don't want to do is you don't want to throw in a bunch of power into that thing without slowly retuning it and kind of going up the ladder like 5 or 10 watts at a time. It creates a bunch of unwanted grid current, and you don't want to load the tubes like that. But anyway, right now we have it loaded with 1500 ohms. That's about, this emulates pretty much this thing at max power, max operation. And the reason why I have this off is because my battery is kind of dying in this Nano VNA, so I wanted to save this for, and not die on me. So okay, here we are. So right now I have this thing pre-tuned. Let's go and zoom in on this thing. So let's see where we're on frequency. Okay. So right now we're looking at a 1.02 SWR on 27th, so this is channel 38, or 1.03, 1.02. Let's see if we can, 1.01, let's see if we can play with it. Oh man, that's sensitive. 0.01. Let's see if we can. I know it doesn't really make a difference, but I'm trying to do this for fun. There we go. 1.0. And look how broadbanded it is. So if you're looking to go from channel like 28 to channel 55, you don't have to make any adjustments. I mean, you can, and you will get like a couple extra watts, but this is what you're looking at. You got a 1.0 SWR, absolutely perfect flat match. And now here for fun, this is what we're going to do. We're going to go, oops, I did not mean to do that. Let's see. So now we're going to go, and we're going to take this down to, let's go to channel something ridiculously low. Let's go to 26.5. 26.3. What we'll do. I want to show you how broadband this thing is. So if you're looking at, I wish this goddamn thing would stay. Goddamn. Okay, so we take our tune knob and we turn left because we're going less, and we're tuning it. And we're almost there. Now we take our load knob and we're tuning it down, down, down. And we got a there we go. We got a 1.02. Now we got a, I'm doing this single-handedly, 1.01 at 26,390. So we're way down on the frequency. Now let's go up and way in a 10 meter band. So if you just go in a 10 meter band, right now we're on, let's go to the top end of the 10 meter band, which is about 29. So right now you have an SWR of 13 without retuning, so that's pretty bad. So now we're going to move up there. Now we actually tune up there and drop that puppy down. And we're going, wish this reflection wasn't here. And of course people are texting me, probably want another amplifier. Okay, so now we're going to go this way. And we're going to drop that bad boy down. And we went from an SWR of 13 to a 1.07, which 1.03. You get the picture basically, 1.02. So we can tune anywhere between 12 and 10 meters absolutely per 1.01. So, and again, you can get this thing tuned out to, so if it tunes, what I'm looking at is if you can tune 10 meter to 12, you can tune absolutely anything in the middle. So this thing, this coil, that means, is absolutely perfect for this situation we got going on. So you got 1.02 at the 10 meter band, obviously. And I'm going to turn this off before it dies. And so we know with that setup, we can tune anything from probably, and like I said, I got it from 12 meters all the way till through the 10 meter band. And I'm not sure. This thing may be able to tune through that. But like I said, I've no desire to test that. I mean, that might do that just for fun, but anything this thing is designed to do, it does a lot more. I mean, it's designed to be around 27, megahertz plus minus 1 megahertz. It's doing way more than that. And it tunes absolutely perfectly with a really, really nice wide cone that if you're just, moving a few channels, you do not need to touch anything. I mean, you could tune to your favorite channel and just leave it there. Anyway, so this is what we got going on. Kind of an update on this. I don't think I mentioned this. This has not been in any of my videos. The customer actually sent me this, and I had one of my own made attachments to here. So the customer will be able to measure power output and reflected power on their external bird meters, which is a really cool setup for your higher end, higher power amplifiers. And this pretty much completes this power amplifier section here. Like I said, I'm going to add a pass-through capacitor and do some pass-through tuning, which I'm probably cover on the next video. I don't know how there's anybody out there gets really crazily excited about pass-through tunes, but I'm not going to make a separate video for it, but I'll put it in my next video. My next video is going to be filling this section up, and this is going to be the final stage before we actually put some power on this. We got let's see, so we have a rectifier board which I actually made custom custom built through one of those PCB websites. This is a really high-end board. This is not a PCB. This is actually a Teflon board. I think it costs like $10, which normally a board is like, I don't know, 2 cents to build. I'm kind of exaggerating, but they're super cheap. You get like 5 for $2, but this is like $10 a board. So these are actually PTFE pre-drilled boards. So this is our rectifier board, and I do have a capacitor bank, which is going to have 33. It's 10 330 microfarad 550 volt capacitors, which if you apply the capacitors in series formula, it's 330 divided by 10, which will equate to 33. We're above 16 what we need, and this is a full wave bridge rectifier, so this is by far more than what we need. This the transformer is going to sit right here. It's going to have a little mounting bracket, and there's going to have its own blower, and the air is going to migrate this way, and there's going to be a hole somewhere here where the air is going to exit out through a little vent. So, and again, as far as the build here, some of you might ask what the purpose of this high temperature fiberglass backer board is, and the reason why is because well, here we have a gap of about 1.25 inches, which is fine, but here this is not high voltage, so this is on the other side, but there's still some high voltage AC present, and there was a gap of about 3/4 inch. So I put this 1/8 of an inch insulator board, and that will guarantee that there's no arcing of any kind going on there. And there's going to be some sleeves I ordered for these things. They're going to go on there. I'm actually going to build them out of Teflon and kind of mount them here with a hose clamp or something like that. And that's it. That's it for this side. And like I said, we'll populate this thing. There's 3 major components other than the meters. Transformer, which is, like I mentioned, it's over there. Rectifier board, capacitor bank. That's it. There's the capacitor bank will have integrated bleed down resistors. There's going to be actually mounted to each capacitor. It's kind of like the SB220 does it. So kind of doing it that way. And we'll have a glitch resistor. It's all in there. It's all going to be in there. And high voltage pass through is going to be somewhere here, which is all it is going to be high voltage neon wire going through a rubber grommet, feeding right into this feed point right here. So very, very straightforward design. And again, like I always say, if anybody has a question, value, number of turns, resistance, this is 1500 ohms, by the way, emulation. Any value that you guys want to know for your own build, please drop me a line. Nothing's a secret here. I know there's some people try to hide stuff or make it hard for newer builders to get in. I'm completely opposite of that. So if you guys want to know a part number or where I got something, where to get something, or what kind of value to use, or how thick of a wire, or how many turns to do, this is 60 turns, 1 inch diameter Teflon rod, 1 inch diameter Teflon rod. Let's see, RG400 for the pass-through, RG393, high quality Jennings vacuum relay rated at 1 million cycles. This is the ones that runs at like $250. This is not the Chinesium ones. I mean, just basically using this 3300 picofarad capacitor rated at 15 kV or 10 kV. Anyway, that's all I can think of as far as values. Anybody interested, drop me a line, and thanks for watching. We'll see you in the next one. Needle Bender 785 Ohio, back on the side.